Hi guys, good morning. So everybody there? Yes, some of you are there. Okay. Only for 2 more minutes. Let people join. Then we'll start. Okay. Right. So guys, are you ready? Shall we start? Guys?
Yes, sir.
Ah,
Yes,
cool.
sir.
Right. So yeah, so we were seeing redox reactions, right? So I introduced you to the concept of oxidation and reduction. I told you that there can be never a reaction where only oxidation is happening or only reduction is happening. So if oxidation happened, reduction will simultaneously happen, right? And we saw some examples for that. And then I told you about oxidizing and reducing agents, right? So oxidizing agents are the one which are getting reduced in the reaction, and reducing agents are the one which are getting oxidized in the reaction, right? Okay. So then we went on to see what is this? Your oxidation and reduction in terms of loss of electron and gain of electron also, right? And then I introduced you a concept of oxidation number, right? So I told you oxidation number is just the charge possessed by that particular element in a particular compound, right? Say now we did so many examples, we calculated the oxidation numbers, and I told you there are certain rules which you have to follow for finding the oxidation numbers, right? So if at all you find elements in their free states, right? So free states are the states where the element is naturally available to us. How do you see it in nature, right? So that and all, if you see, you have to put the oxidation number as 0. And I told you for group 1 elements, it is going to be +1. For group 2 elements, it is going to be +2. For oxygen, right, I can have -2 for oxides, -1 for peroxides, and -0.5 for oxygen in
Superoxides.
in superoxides, right? And then we went on to see, and okay, oxygen can also have a positive oxygen state only in one compound, and that is my OF2, because fluorine is the only element which can have more electronegativity than oxygen, right? So in that compound alone, oxygen is going to have a oxygen state of +1, +1, +2, right? Okay, so then we went on to see what to say hydrogen, right? Hydrogen can have +1 or -1 depending on whether it's with lesser electronegative element or more electronegative element, right? And then we went on, then we saw so many examples, right? And then what we realized is just by just by doing the normal method, just putting x and equating it to the total charge, that is 0 or whatever the charge is, that might not fetch you the results all the time, right? Say sometimes you will have something called as mixed oxides, like Fe3O4 was a very good example, right? So Fe3O4, there were two oxidation states simultaneously existing for iron, +2 and +3, right? So, and then we went on to see if it is ammonium nitrate, right? Ammonium, in ammonium ion, I have nitrogen. There I'll have a negative oxidation state. In nitrate, NO3 minus, in that case, nitrogen is going to have a positive oxidation state. So again, if you cannot calculate directly, saying that there are two nitrogen atoms and I will calculate, no, you cannot do it like that. And then we saw certain molecules, you will not be able to directly predict the oxidation numbers. You have to know the structures of these molecules, right? So we saw again for that also, we saw so many examples, right? So that is where we stopped last class, right? Cool. So now what we're going to do is we are going to have a new definition, right? We are going to have a new definition for oxidation and reduction, right? In terms of oxidation number, right? In terms of oxidation number, I will be able to give you a new definition for oxidation and reduction, right? Okay, so we'll see what is that. Right. So in case of oxidation, right? In case of oxidation, right? You will see that there will be an increase in the oxidation number of an element, right? There will be an increase in the oxidation number of the element. Okay. And in case of reduction, you are going to see just the opposite. You are going to see a decrease in oxidation number of that particular element, or any element for that matter. If you find that there is decrease in oxidation number, I would say that that particular element is reduced, right? Now, very simply, I will be able to tell this, right? Now, let me go back to the question. I told you that I will be explaining how this particular reaction is a redox reaction. You told me when I asked you this question, right? You told me that it is going to be a simple oxidation reaction, but I denied your point, saying that no, this is going to be a redox reaction. Now I'll prove it to you, right? So fine. Now let me go for it. Now tell me, what is the oxidation number of carbon here? Guys, what is the oxidation number for carbon here?
Sir,
This carbon which I have here, what is the oxidation number?
Four, sir.
4, sir.
What is it? It is
2, sir.
Say I'll put it as graphite, right? So the thing is, guys, carbon here is in its free state. Like carbon is a, we cannot call it as a metal or a non-metal, but still it is existing in its free state, isn't it? Do you see carbon as any kind of molecule like C2 or C4, something like that? How we say hydrogen or oxygen?
No, sir.
No, right. So carbon exists as carbon only, right? So when I see just carbon like this in any reaction, right? No, like it is going to it is basically indicating that it is existing in its free state. What is the oxidation number?
0, sir.
0, sir.
So it's 0 for carbon. Okay, for oxygen here,
-4.
-4.
-4.
seriously. After all this is what you tell me.
0, sir. 0, 0, 0.
0, sorry.
Thank you so much. Okay, so again for oxygen, again it is existing in its free state, right? For oxygen it is 0. Okay, so now let me go to that. Now you are going to calculate. When I go to carbon dioxide, yes, you will calculate it. Okay, fine. Now I have to, now for oxygen, what will be the oxidation state in carbon dioxide?
-4.
4, sir.
4,
Guys,
sir. 4, sir. Sorry.
listen. Right, don't panic. So the thing is, fine, let me ask you this question. Okay, so if I had say H2SO4, right, and I ask you what is the oxidation state of oxygen here, what will you answer? Will you say it is -8?
No, sir.
What will you tell it as? See, please understand, irrespective of how many atoms of that particular element is there, again I repeat, irrespective of how many atoms of that particular element is there, oxidation number talks about for one atom, what is the charge? Please understand that, right? For one atom, how many ever atoms are there, right? For one atom of that particular element, what is the charge is what is my oxidation number, right? So in this question, in this H2SO4, if I ask you, what is the total charge possessed by oxygen? Then I will say it is -8, right? But if I ask you, what is the oxidation number of oxygen here? It's -2, that's it. You don't have to worry about how many number of oxygen atoms I have. Please get it to your head, right? It is not at all about how many oxygen atoms I have in the molecule, right? Say I can give you one example like this. Say if you take H2O for example, right? I obviously know oxygen is going to have -2 here. There is no doubt about it. If I ask you what is the oxidation number for hydrogen, what will you say? What is the oxidation number for hydrogen? If I ask you in H2O, what will you answer?
One.
Exactly, right? So you now will calculate, right? So you say that it is 2x minus 2 is equal to 0. 2x because there are 2 hydrogen atoms and x is the oxidation number, right? So 2x is equal to 2. So x will be +1. This is for each of the hydrogen atom. Both the hydrogen atom has +1 and +1. You should not tell it as +2 just because there are 2 hydrogen atoms. I mean, just because there are 2 hydrogen atoms. Are you able to understand, people?
Yes, sir.
Right? So it is not at all about how many atoms are there. It's all about for that element, for that one particular atom, what is the charge, and that is my oxidation number. Right? Okay, now tell me what will be the oxidation number for oxygen in CO2?
-2, sir.
That's it. As simple as that. -2. Okay, now what will be the oxidation number for carbon?
2, sir.
Calculate.
4, sir.
Correct. It is going to be +4. How it's +4? X is for carbon, right? And I have 2 oxygen atoms, each having -2 as the charge. Totally it is 0. So X is +4. So carbon is in +4 oxidation state. Everybody understood how it is +4 and -2? Right? Okay. Now we'll see what is happening to carbon and what is happening to oxygen in this particular reaction. Right? So carbon in the reactant side, right? Carbon in the reactant side had your oxidation state as 0. Right? Now, if you go to product side, what happened to carbon is carbon has an oxidation number of 4, +4. So what did I tell you? Whenever you see there is an increase in oxidation number, whenever you see there is an increase in oxidation number, it is going to be called as oxidation. So I can easily say that carbon here is the one which is getting oxidized. Is it not? Because I have 0 to +4. It is increasing from the reactant to product side. Carbon's oxidation number is increasing. Okay, fine. What about oxygen? Oxygen was in 0 oxidation state in the reactant side, right? Now in the product side, what I see that oxygen is now in -2 oxidation state, right? What happened here? I had reduction, like basically I have a decrease in oxidation number, isn't it? 0 to -2, right? It is decrease in oxidation number. So I can easily say that oxygen is the one which is getting reduced, right? So this definition holds good, right? If you see that for a particular element between the reactants and the products, you saw that there was an increase in oxidation number, it is going to be oxidation. And for the same case, if you see a decrease in oxidation number, it is going to be called as reduction. So yes, so this particular reaction is not an oxidation reaction, this is a redox reaction, right? Okay, fine. So we'll take more examples like this. Okay, so we'll take simple reaction, like the reaction which we already saw, or we can take okay, fine. I have MnO4 minus reacting with Fe2 plus, becoming Fe becomes Fe3 plus, and M becomes Mn2 plus, assume like this, right? So this is an ionic reaction, right? Okay. So basically, what I'm trying to tell you from this reaction is basically when I say MnO4 minus is what is called as your permanganate ion. Hope you remember KMnO4. It is potassium permanganate, right? So potassium is potassium ion, and if I just remove the K plus, what I have is MnO4 minus. So MnO4 minus is going to be called as your permanganate ion. Okay, fine. So now this Fe2 plus Maybe it can be a salt. Say this, I will be, instead of this, I can even write it as FeCl2, right? So you can easily see that iron is in +2 oxygen state. So I just removed the 2 chlorines and I just wrote the iron molecules, right? Anyways, doesn't matter. So we have, what we are trying to understand here is which is getting oxidized and which is getting reduced. Can you tell me, looking at it, which is getting oxidized and which is getting reduced? Calculate the oxidation numbers of all the elements, whatever is there in this reaction, and check which is undergoing oxidation and which is undergoing reduction.
So Fe is undergoing reduction, sir.
Fe is undergoing reduction. Okay, we'll check. Fine. What is the oxidation number for iron here? In the reactant side, what is the oxidation number for iron?
+2, sir.
Yes, +2. There is nothing to calculate. Directly charge is given. So it is definitely going to be +2. Okay. So what is the oxidation number for iron in reactant side?
+3.
+3. Okay. What is happening here? Is it increasing or decreasing?
Increasing, sir.
Increasing. So what is happening to iron?
Oxidation.
That's it. So iron is the one which is getting oxidized. Okay. Fine. Now let me calculate for manganese, Mn. Oxygen, you said you can calculate actually, because, but the problem is in the reactant side I have oxygen, in the product side I don't have oxygen. We don't have to worry about it. I will teach you how to balance the chemical reaction with the help of these oxidation numbers, right? At that time you will be able to get a balanced equation, so you don't have to worry about it. Okay, so for now we'll concentrate on manganese. Okay, now tell me what will be the oxidation number of manganese here?
7, sir.
Yes,
7.
+7, right? So it is going to be X for manganese, and I have 4 oxygen atoms each having -2, and that has to be equal to the total charge. Total charge here is -1, right? So obviously you'll get X as +7, right? So here manganese is in +7 oxidation state. Okay, now here in product side, what is the oxidation number for manganese?
+2.
+2, right? Obviously. So they are directly giving you the charge. You don't even have to calculate. So what is happening? So from +7 to +2, there is obviously a decrease in the oxidation number, right? So definitely I would say that manganese is the one which is getting reduced here. Again, I repeat, increase in oxidation number, oxidation, decrease in oxidation number, reduction. As simple as that, right? Okay, fine. So now we understood how oxidation and reductions are going to happen with respect to your oxidation numbers, right? Now what you're going to do is use all these things, whatever you have learned till now, that is knowing that which is getting oxidized, which is getting reduced, calculation of oxidation numbers, all these knowledge, whatever I have with me now, right? Now I'm going to use it for balancing a particular chemical reaction. You already know how to balance the chemical reaction by normal method, isn't it? Right? You will go for trial and error. You put 2 here, 3 here, whatever it is, you will be able to balance, right? Now there is one more way of balancing which you can do, right? So what you're going to do here is we are going to take the oxidation numbers, and that is going to help them. That is going to help us. What is that? To balance the chemical reaction. Okay, but then again, there are certain rules which you have to follow, right? I would say not rules. You just have to follow the guidelines which I'm going to give you now. Okay, so if you follow the guidelines very properly, easily, in like minutes, you will be able to solve. You will be able to balance the chemical reaction. Okay, fine. So we are going for balancing of a redox reaction, right? And obviously you have to follow the steps for balancing a redox reaction. Okay, right. Right, so we'll take down the We'll tell you the rules for this. Right. Okay. First step here is that you have to identify. Right. You have to first identify which is getting oxidized and which is getting reduced. Say first. Now this kind of reaction is given to you. Obviously, it is not balanced. I know that because in your product side I have oxygen. In the reactant side you have oxygen. Product side you don't have oxygen. So obviously I know that this is a skeletal equation. What do you mean by skeletal equation? Which is not balanced, right? So I have my skeletal equations here, right? So first you write down the equation. That's actually the first step, right? You write down the equation. Okay. Now after you write down the equation, the next thing you're going to understand or identify is you're gonna do this. Identify which is getting oxidized or which is getting reduced. So I can call it as identify the oxidant and the reductant. What do you mean by oxidant and reductant? Oxidant is the one which is getting oxidized. Reductant is the one which is getting reduced. Okay, so like just now we understood how to do that, isn't it? In this case, iron is getting oxidized and manganese is getting reduced. Like this, you have to first decide. Okay, fine. That's the first step. Now, second step. Right. Now, after you identify which is getting oxidized, which is getting reduced, I think I'll use a better marker. Right. So after identifying which is getting oxidized, which is getting reduced, you are going to write the half reactions. Write down the half reactions. Right. What do you mean by half reaction? Half reaction basically talks about the oxidation reaction separately and reduction reaction separately. What I'm trying to tell you is this. Say I had this reaction, right? I had Fe3 plus or Fe2 plus reacting with MnO4 minus, right? Giving Fe3 plus Mn2 plus. Okay, I have this reaction with me, right? So when I say half reactions, and obviously you have to write the half reactions along with the number of electrons. Along with the number of electrons you have to write, right? What do you mean by number of electrons? I already know that oxidation is where the element or the compound loses electron, isn't it? Oxidation is where there is loss of electron, and reduction is where I have gain of electrons, isn't it? So obviously you can understand that that thing will definitely happen here, right? That thing will definitely happen. That is, for oxidation I have to lose electron, for reduction I have to gain electron. All these things would have already happened, and that is the reason why you are even seeing a change in oxidation number, isn't it? That's the because say now I know that Fe has become Fe2 plus has become Fe3 plus. How?
Because of oxidation.
No. How, I mean, in terms of electrons.
Decrease in number of electrons.
Sorry?
Decrease in the number of electrons, sir.
Decrease in the number of electron, or in a better word, I can say that Fe2 plus has lost electron.
Loss
Right,
of
like that?
electron.
Okay, right. So Fe2 plus has lost one electron to form Fe3 plus. Right? So you have to write it like this, right? How will you write it? Is that, say, first I will take, so your first thing is you have to understand or identify which is oxidation, which is getting oxidized and which is getting reduced. And after doing that, you are going to write two reactions. One for the oxidation half reaction, and second for the reduction half reaction. And most importantly, you are going to write it along with the number of electrons lost or number of electrons gained. Both. Right. Okay, we'll see how to do this now. So I have Fe becoming Fe3 plus. So Fe2 plus would have become Fe3 plus by the loss of one electron. This is my oxidation half reaction. This is my oxidation half reaction. Very simple, right? Okay, now we'll go for the other one, that is manganese. Manganese is the one which is getting reduced. Okay, so I know manganese MnO4 minus is becoming Mn2 plus, and we already calculated what will be the oxidation numbers on both sides, right? So we calculated it as +7 for manganese in the reactant side and +2 for manganese in the product side. Correct? Right? So for this to happen, for +7 to become +2, first you tell me, electrons has to be accepted or gained. I mean, electrons has to be accepted or it has to be lost.
Accepted.
Definitely, right? Because +7 is becoming +2. There is decrease in positive charge. So definitely I would have added electron to manganese. How many electrons? How many electrons would have been added?
5, sir.
5.
Wonderful, wonderful. It is 5, right? So obviously, if I add 5 electrons to manganese, that is MnO4 minus, +7 will become +2. This is how you write it. Or if I write it properly, wait. I'll write it as MnO4 minus, which is having +7 oxidation state, accepts 5 electron to form Mn2 plus, which is in +2 oxidation state. Easy, right? First 2 steps are very easy. You identify which is getting oxidized, which is getting reduced, and then you write the 2 half reactions, along with the number of electrons lost and gained. Very, very simple. Okay, right. Now, after doing this, after you write down the half reactions, okay, now what you're going to do, third point, is you are going to make the number of electron lost to be equal to number of electrons gained. What are you going to do? You are going to do something, right? So that the number of electrons lost in the oxidation half reaction should be equal to the number of electrons gained in the reduction half reaction. Okay. So what we'll try to do, basically, we'll try to multiply it by a number, isn't it? Right? So now you can, okay, I'll take this example itself. Now you can see that Fe2 plus is becoming Fe3 plus by losing 1 electron. And MnO4 minus becomes Mn2 plus by accepting 5 electrons. Now what I'm telling you is, now here the number, some electrons are lost, here some electrons are gained. These two should be equal. Okay. Now what will you do? You tell me.
Multiply that electron first one for iron with 5.
So you cannot just multiply the number of electrons alone. You have to multiply whole reaction by 5. Is it not? You have to multiply whole of the reaction by 5. Correct? So if I multiply this by 5, now what will happen? Now I can write it as 5 Fe2 plus becomes 5 Fe3 plus 5 electrons. I write the other one, I'm not doing anything, right? So now sometimes what happens is in this case, you're multiplying only one of the reaction by a number, right? Say, assume that in some reaction, oxidation, the number of electrons lost were 2, right? And reduction, the number of electrons lost were 3. Now what will you do? Obviously, the first reaction has to be multiplied by 3, second reaction has to be multiplied by 2, so that you'll be able to make the number of electrons to be equal to 6. So anyways, now in this case, I'm multiplying only the first reaction, second reaction is as such, right? Now what will I do? I will write the second reaction as such, MnO4 minus, accepting 5 electrons to form Mn2 plus. Very, very simple, right? Now what I'm going to do is, now I'm going to add these reactions and write the overall reaction, right? I'm going to add this reaction and write the overall reaction. Now what happens here? 5 electrons will get cancelled. This is the reason why you are doing it. When I'm going to write the overall reactions, there should not be any electron there. And that is the reason why we are making sure that the number of electrons lost and the number of electrons gained are somehow made to be equal. Right? Now when I write the reaction, how will I write the reaction? 5 Fe2 plus, and what other things in the reaction side? MnO4 minus gives 5 Fe2 plus, sorry, 5 Fe3 plus, I'm sorry, right, 5 Fe3 plus, and what is there? What else is there? Mn2 plus. Done, right? So again, I repeat from the first point. First point is you have to identify which is getting oxidized, which is getting reduced. Good. Second, you have to, after identifying, write the half reactions, oxidation half reaction, reduction half reaction, along with the number of electrons lost and gained. Okay. After doing that, you are going to suitably multiply these two reactions with some number so that the number of electrons lost and the number of electrons gained are going to become equal. And that's what we did. And after doing that, I added the two half reactions to get the overall reaction. Done. Any doubts till now? Don't worry, we'll see a lot of examples.
Sir, is
Right.
there any alternative method?
Yes, there are. I can directly use this your oxidation number method. There are two methods actually, right? But if you know any one of them, it's better because you don't have to get confused. And this method is far easier. And what to say, like oxidation number method can become little complex certain times. Okay, so it is better to use this method. And they will not ask you, solve by this method only. Nothing like that. You can directly go. You can use any of these methods. And I prefer this method because it is easy for you to understand, right? And it is going to be little less complex when compared to the other method. Is it okay? Right? Okay. Moving on, what should be the next step? Right? What should be the next step? Next step after doing this, right? Now in the question, right? In the question, they would have given you whether the reaction is happening in acidic medium or whether the reaction is happening in basic medium or in neutral medium. And most of the times they will not give you neutral medium. They will either give you acidic medium or basic medium. Okay, so acidic medium in the sense I have some amount of acid present here. Basic medium in the sense I have some amount of base present. Right. Now, depending on that, you are going to do something. What you are going to do is you are going to do charge balance. Right. You are going to do charge balance between the reactants and the products. Right. You are going to do something called as charge balance between the reactants and products. Okay, what is this? Fine, we'll try to do that. Okay, so this is the last step reaction I got. Okay, now let me calculate what is the total charge possessed by the reactants in the reactant side and what is the total charge possessed by the products in the product side. Okay, let me calculate. Let me write it. Okay, let me write it again actually. So I have 5 Fe2 plus MnO4 minus gives 5 Fe3 plus Mn2 plus. Yes, this is what I have. I just wrote the same reaction. Okay, fine. Now let me calculate what is the charge. Now I have Fe2 plus. So here the charge is plus 2. But how many Fe2 plus I have? I have 5 Fe2 plus. Isn't it? So what is total charge here? Total charge for in this case alone, it will be plus 10. Sorry. Right? So in this case alone, it will be plus 10. And I have one more charged compound, and the charge here is minus 1. So can I say it is plus 10 minus 1? So can I say in the reactant side, I have plus 9 to be the charge? Okay,
Yes.
fine. Right. Now going back here, going back to this, right? If you look at here, I have Fe3 plus, so plus 3 is the charge, but there is not one Fe3 plus, but there are 5 Fe3 pluses. So I have 15 for Fe3 plus 5 into 3, 15 plus. I have Mn2 plus, there is only one Mn2 plus, so it is 2. So 15 plus 2 is 17. Oh, okay. So now what you have to do is you have to do something to these so that this becomes equal. Right? You have to do something to these numbers so that it becomes equal. Okay. Now what we are going to do? Now I told you this all what we are going to do is going to depend upon what kind of medium is given in the reaction. Okay, what kind of medium is given in the reaction. Okay, so what will happen is generally they will give acidic medium or basic medium, right? Now, if they give acidic medium, right? If they give in the question that the reaction is happening in acidic medium, you are going to add H plus on one side, right? You are going to add the H plus on one side, right? And obviously some hydrogen wouldn't have been, like, say, if you add it in one side, that particular side will have more amount of hydrogen and the other side will not have any hydrogen, right? Okay, actually before all this, there is a point which you have to know, right? So whenever you're going to balance this redox reactions, right, other than hydrogen and oxygen, whatever the other elements which are there in those particular reaction, only for those molecules or only for those elements I will try to balance, right? For hydrogen and oxygen, I will balance them only at the last step. This is the last step, right? For hydrogen and oxygen, if they are there already present in the molecule, I mean, present in the reaction, right? Even though they are present, you don't have to worry about them. They will eventually get balanced at the end of the reaction, right? At the last step of the reaction, last step of balancing, I would say, right? Last step of balancing, I'll be able to balance my hydrogen and oxygen. So till now, till you go for charge balance, do not touch hydrogen and oxygen. Okay, right. So now we'll try to do something. So I told you, if it is acidic medium, you are going to add H plus, means you don't have to add only one H plus, some number of H plus. Add H plus on one side, right? To counteract it, what you have to do? You have to make sure that you are adding water. So if you add H plus on one side, right, and add H2O on the opposite side. Say for example, you added 2H plus on the reactant side, right? You added 2H plus on the reactant side. So obviously the reactant side has 2 hydrogen, product side has nothing. So how we are going to compensate? You are going to compensate by the addition of water in the product side, because I told you, if you add H plus on one side, that is the reactant side or product side, you have to add H2O on the opposite side. That means if you add H plus in the reactant side, you will add H2O in the product side. Because obviously, okay, if you add it on the same side, what is the point? Again, one side will have more number of hydrogens, isn't it? So I'm telling you that if you add 2H plus, for example, 2H plus you added in the reactant side, right? So now tell me, how many water molecules will you add in the product side? Did you understand my question?
One molecule.
Exactly. I'm going to add one water. So what I'm telling is, so there is reactant side, product side. I have some reaction happening. Okay. So I added 2H plus. After doing all these things, I'm going for charge balance, and I understood that there are 2H plus required for me to do charge balance in the reactant side. Okay. Right. Now, if I added 2H plus, I'm asking how many molecules of H2O should be added on the product side. You just have to make the number of hydrogens equal. So obviously, I know in one molecule of H2O, I have 2 hydrogens. Done. So I just have to add 2 molecules of H2O. That's it. Very, very simple. Okay, right? Now, if it is going to be OH minus, right? If it is going to be basic medium, that is obviously now you cannot add H plus, you have to add OH minus, isn't it? Right? So in this case, what you're going to do, exactly the opposite of this, add OH minus to one side, and obviously to counteract your hydrogen and oxygen, you add H2O on the opposite side. You add H2O on the opposite side. Okay, so very, very simple. So how many steps? Just 4 steps, right? What and all? We'll try to do this now. First we'll see what all the 4 steps. So first you have to identify which is getting oxidized, which is getting reduced. Second point, you have to write the half reactions, oxidation half reaction, reduction half reaction, along with the number of electrons lost. Third step, you have to make sure the number of electrons lost and number of electrons gained are made equal by suitably multiplying with numbers, right? And then you add these 2 half reactions, get the overall reaction. Then last step, is about charge balance. You are going to calculate the total charge on the reactant side and the total charge on the product side, and you are going to make them equal. How will you make them equal? You have to look at the question and see which medium they have given you, whether it's acidic medium or basic medium. If it is acidic medium, add H plus on the required side and H2O on the opposite side. And if it is basic medium, add OH minus on the appropriate side and add H2O on the opposite side. Okay, right. Now let me take this example itself, right? And let us assume that this reaction has happening in acidic medium, right? This reaction is happening in acidic medium. Okay, right? So if it is acidic medium, right, now I understood that in the reactant side I have only plus 9, right, and in the product side I have plus 17, right? In the product side I have plus 17. Oh, okay. So now what we are going to do? You tell me. If it is acidic medium, I have to add H plus. Yes, right? I told you this is acidic medium. The question is given, right? This is happening in acidic medium. Okay, so it is understood that I have to add H plus first. Where will I add? Will I add it in the reactant side in this case or in the product side? You tell me.
Reactant, sir.
Okay, yes, it is reactant side. How many H plus I have to add?
8, sir.
Yes, exactly. So to this reaction, if I add 8 H plus in the reactant side, right, now what happened? Already I had 9, right? I have to make it equal to 17, correct? So now I have to make sure that here also I have to add 17. So now if I add 8 H plus, so obviously plus 1 is the charge for hydrogen, and there are 8 such things. So 9 plus 8 will become 17. So you saw that the charge was balanced, right? Plus 17 on this side and 17 on that side. But again, it's not yet over. What you have to do? You have to balance for hydrogen and oxygen also, right? So easy. How we can balance here? I have 8 H plus. That means I have 8 hydrogens to balance. So obviously, how many water molecules I have to add
4,
on the
sir.
product side? Exactly. So plus 4 H2O. Right? So you have 8 hydrogens, 4 oxygens, charge is balanced, 5 Fe, 1 Mn, everything is balanced. Okay, everything is balanced. So you just have to follow the steps very, very carefully and do it slowly. You will be able to get the answer very, very easily. Okay, fine. We will take more examples. Don't worry. Right. Okay, I'm looking for a reaction. Okay, let me take this reaction. Okay, I will take okay. So here I have Cl2 plus IO3 minus gives 2Cl minus, oh sorry, Cl minus plus IO4 minus. Right, okay, this is the reaction, right? Cl2 plus IO3 minus gives Cl minus plus IO4 minus. Okay, fine. Now again I have to balance it, and it is given that the reaction is happening in basic medium. The reaction is happening in basic medium. Okay, fine. So this I will do, like you can do parallelly with me. Okay, fine. Now we'll just follow the steps. Now we have written the reaction, right? Now we have to understand which is getting oxidized and which is getting reduced. For that, we need to know the oxidation numbers. Okay, first we'll start. What is the oxidation number here for chlorine?
0.
Yes, 0, because chlorine is in its free state. 0. Okay, now I have to calculate the oxidation number for iodine. Again, first thing, you don't have to worry about oxygen. There are oxygen atoms here, you don't have to worry about them. At last, we'll take care. Okay, so I have to calculate what is the oxidation number for iodine. Can you calculate and tell me what will be? What it will be? Sorry?
5, sir.
5, huh? Yeah, it should be 5. Correct. So it should be x minus 6. How minus 6? 3 into -2. So minus 6 is equal to -1. So yeah, x is plus 5. Here it is plus 5 for iodine. Okay. Here for Cl minus, what is the oxidation number? Cl minus. That's it. -1. Very simple. So directly it is given charge, right? So -1. Now I have to calculate the iodines is not molecular mass. Iodines is oxidation number in IO4, 1 minus. What it will be?
7, sir.
Yes, plus 7. Exactly. So again, have x minus 8 is -1. So x is plus 7. So here it is plus 7. Okay. Now we have to understand which is getting oxidized, which is getting reduced. You tell me quickly which is getting oxidized, which is getting reduced.
Iodine is getting oxidized.
You should not say IO3, you should say iodine is the one that's getting oxidized. It always should be about elements, not the compound as a whole. Compound as a whole cannot get oxidized, cannot get reduced. It's only the elements. Okay, so you have to say, you can see that here it is plus 5 for iodine, here it is plus 7 for iodine. Obviously there is increase in oxidation number for iodine in the reaction. So iodine is the one which is getting oxidized. Okay, now what happened to chlorine? Chlorine was 0, right? But it is becoming -1.
It's
Right? It's becoming -1, so definitely chlorine is reduced. Okay, fine. Now what is the next step after doing this?
Write half reactions.
Correct. So we have to write the half reactions. We'll do that. You do that first. I'll also do. Right. So now I'll take the chlorine first. Right. Now you have Cl2 becoming Cl minus, and guys, you have to do certain things here. Right. Now first, what you have to understand is, you are seeing that there are 2 chlorine atoms in the reactant side, but there is only 1 chlorine atom in the product side, right? So first itself, you will put a 2 here. Don't forget this. Okay. Now last time what we saw, there was 1 manganese in the reactant side, 1 manganese in the product side, 1 iron in the reactant side, 1 iron in the product side. But here it is little different. What happened? Here I have 2 chlorine atoms. Here I have only 1 chlorine atom, so I put a 2 here. Okay. Now I know that it is getting reduced, so that means it is accepting electrons. How many electrons? You tell me.
1 electron.
Correct. So what you see is, you have 1 Cl to become 1 Cl minus, I require 1 electron. How many Cls are there?
2 C.
So it should not be 1 electron, it should be 2 electrons. Guys, any doubts here? Why am I putting 2 electrons here? For 1 chlorine atom to become 1 chlorine ion, or say 1 Cl minus ion, I require 1 electron. But here I don't have 1. Here I have 2 chlorine atoms becoming 2 chloride ions. So it should be 2 electrons and not 1 electron. See, this and all are the small points you might miss. Be very careful. Okay, fine. So here it is 2 electrons. Okay, now that's the first half reaction, reduction half reaction. Moving on to the oxidation half reaction, IO3 minus becomes IO4 minus. So what is happening here? You are seeing that, okay, it is plus 5 to plus 7, right? So what will be the, obviously electrons has to be lost. How many electrons?
2 electrons.
Wonderful, 2 electrons. Right? Okay, now what you have to do? I have to make sure that the number of electrons, okay, now you tell me. Fine, actually, I already told you, fine, I will tell you. Right? So the next step is you have to make sure the number of electrons lost and the number of electrons gained are equal. Now, in this case, like lucky for you, already it is equal. Why? Because you saw that there are 2 electrons here and there are 2 electrons here. So you don't have to multiply anything. Right? So now directly I can add them, cancelling the 2 electrons. Right? But if you have done the mistake of writing 1 electron here, gone. Isn't it? You would have multiplied this by 2. No, it's not good. Right? Okay. So now I'll write the reaction now. Cl2 plus IO3 minus gives 2Cl minus plus IO4 minus. Done. Right? What is the next step? What is the next step? After this?
Charge.
Charge balance.
Correct. So we have to go for charge balance. So I have to calculate the amount of charge in the reactant side, amount of charge in the product side. Now tell me, what is the total charge in the reactant side?
-1, sir.
Yes, very good. -1. There is only one IO3, one minus. There is only one ion like that. So it is -1. Okay. Now here, what is the charge in the product side? Total charge.
-3, sir.
Yes, it is -1 second, people. My marker. Gotcha. So yeah, so it is -2 for 2 chlorine atoms, 1 Cl minus. There are 2 Cl minuses, so -2, and there is one IO4 minus. So -2 -1 will become -3. Okay. Now, in the question they have given that it is going to be in basic medium. So what should I add?
OH minus.
OH.
Okay, fine. I have to add OH minus. In this case, which side I have to add OH minus?
Reactants.
Okay, obviously, because in this case it is more negative, it is less negative. So I have to add more negative to the reactant side. You can keep it like that, isn't it? This is -3, more negative, -1, less negative. So I have to make them equal. And in this case, they have given only negative charge to us. Basically, what? Negative charge in the basic medium. So you have to add only OH minus. That is a negative charge. So you have to add more negative charge to the reactant side. Okay. How many? How many OH minus?
2, sir.
Wonderful. Right. So obviously I have to add 2 OH minus here. Why? Because I have to make this -1 equal to -3. So I already had -1. Now this OH minus will give me -2. So -3 is equal to -3. Okay. Right. Now you have to calculate the total number of oxygen atoms, and accordingly you have to balance the reaction. Right. Okay. So now I have 3 plus 2, 5.
Sir, doubt.
Right? 3. Yeah.
You don't have to add H2O, sir.
We have to, that's why I'm calculating. We have to add H2O on the opposite side. That's why I'm calculating how many number of oxygen atoms I have, and accordingly I'll be able to add.
Okay, sir.
Right? So you can see that there are 3 here plus 2 here. 5 in the reactant side, 5 oxygen atoms in the reactant side, 3 plus 2. Right? And here I have 4 oxygen atoms. Right? So obviously what is the deficit? Deficit of 1 oxygen atom is in there in the product side. Right? And there is also a hydrogen atom here, and there are no hydrogen atoms there. Right? Okay, so obviously, so to counteract your oxygen atoms, there is only one deficit of oxygen atom. So I can directly add 1 H2O. Very, very simple. I can have that 1 H2O. Very, very simple. Everybody understood what I did here? Same steps. The same 4 number steps, a different reaction. That's it. Right? Okay. Now you will do one problem very quickly. I'll give you. Okay. Okay, so let me have this. I have Cr3 plus reacting with Fe2 plus, becoming Fe3 plus, right? And I have it is becoming Cr. Oh, I'm really sorry. This is not Cr2 plus. This is Cr2O72 minus, becoming Cr3 plus, and it is given in acidic medium. Okay, it is given in acidic medium. Now I know what is the Cr2O72 minus. It is K2Cr2O7. From that I have removed the two K plus ions. Very simple. So this is my potassium dichromate, and in this case it is called as my dichromate ion. Okay, go for it. Balance and tell me the answer. I'll give you 2 minutes. Quickly do it. Now again, just like last time, you had here I have two chromium atoms. There is only one chromium atom. So remember what we did there. Yes, I think the 2 minutes got over. You got the answer? Yes, people. Did you?
Doing so.
Okay. Okay, fine. We'll stop it there. Whatever you're doing, we'll stop. You will help me do it. That will be better. Everybody can engage here and answer me when I ask you questions. That will be better, right? So you will help me now. Fine, guys. Tell me what is. Okay, fine. What is the oxidation number of
Sir, what
chromium
is
here,
the
people?
medium?
Acidic medium. Okay, fine. So guys, tell me what is the oxidation number for chromium here?
+6, sir.
Yes, +6. So 2x minus 14 equal to -2. So x is plus 6. So chromium is having here +6. Okay, and easily I can tell that what will be the oxidation state of iron? +2. Here it is +3, and there again it's directly given here it is plus 3. Okay. The next step, we know we have to write the half reactions. Right. So let me take first chromium. So Cr2072 minus becomes Cr3 plus. What do you have to do here? First step, what is this? Tell me.
Have to put 2 in the
Correct.
product.
So you have to put 2 in the product side. First, you have to make this equal. Okay. Now, I see that plus 6 is becoming plus 3. So obviously,
Losing 3 electrons.
oi, it's losing 3 electrons.
Gaining.
Gaining 3 electrons.
Correct. So gaining 3 electrons. Correct. So 1 chromium 6 becoming 1 chromium 3, I require 3 electrons. But how many chromiums I have? 2 chromiums. So if at all you would have put 3 electrons, hit yourself. Here it is going to be 6 electrons. Correct? Right? So now I'll tell you. For 1 chromium 6 plus 2 to become 1 chromium 3 plus 3 electrons, I accept. Right? But how many chromium atoms are there? 2 chromium atoms are there. So it is not 3 electrons, it is 6 electrons. Right? So here I should add 6 electrons to the reactant side. Okay, fine. One half reaction over. Next, Fe2 plus becomes Fe3 plus. Now I can easily say that there is only 1 electron lost. Okay. Now what I have to do? Tell me. Now what has to be done? Sorry? Balance. I know balance. What do you have to do for balancing? In this next step.
You have to make number of electrons lost equal to gain.
Okay, fine. We have to make the number of electrons lost and gained to be equal. For that, what do you have to do?
We multiply it with 6.
Multiply what by what? Which reaction? Say if I call it as first reaction, second reaction, which reaction I have to multiply?
Second with 6.
Second reaction by what number?
6.
Obviously, right? So this reaction has to be multiplied by 6. Why? Because there are 6 electrons here. There is only 1 electron here. So if I multiply this whole reaction by 6, this 6 electron and 6 electron gets cancelled. Very good. Okay. Next, I have to write the overall reaction. So I have Cr2072 minus 6 electrons will get cancelled. And I have 6 Fe2 plus becomes 6 Fe3 plus, and what is remaining is 2 Cr3 plus. Okay, what is the next step?
We do charge balancing.
Okay. Can you calculate the charge and tell me here quickly? What will be the charge?
Be 10, sir.
Sorry, I didn't hear.
10, sir.
10, no? Okay, fine. So here obviously 10. So here I have 6 into 2. So for this it is plus 12, and here I have a minus 2. Right? So totally the charge here is plus 10. That is 12 minus 2 is 10. Okay. Going there, what is the charge?
24, sir.
Okay, so I have 6 into 3, 18, right? 6 into 3 is 18 plus 2 into 3 is 6. So total here is 24. Okay. Now they have given acidic medium. Okay, so we know we have to add H plus. H plus to what side?
Reactant side.
Very good, right? So here I have more positive, less positive. So I have to make this more positive. So definitely I have to add H plus in the reactant side. How many?
14, sir.
Definitely, right? Very good. So I have to add 14 H plus. Now what happens? I already had 10. Now I have 14 H plus, that is 14 positive ions. So plus 14, if I do, so this will become 24. Very good. Charge is balanced. Now what I have to do?
We have to add H2 on the product.
How many?
7, sir.
7.
Wow. Wonderful, right? So I have to add. Now there are 14 H plus, so 14 hydrogen should be there. So definitely I need to have 7 H2O molecules on the product side. I think everybody would have gotten a grasp, isn't it? Right? So now tomorrow's class, we will be taking some special redox reactions called as disproportionation and conproportionation. I think it would have already been taught in your school. but we'll see that again, and then we'll see how to balance them also. Okay, fine, guys. Until then, thank you so much. Bye bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.